Hello, Algebra 2. This video lesson for Chapter 5.3 will have us finding square roots and using those square roots to solve quadratic equations. Essentially, in this video, I'm simply going to read along looking at the textbook with you. And that's because I found that students often find Chapter 5.3 confusing when they try to read it themselves, but the material in the chapter itself and what the textbook authors have put together, I feel, covers the material perfectly fine, and if I talk it through with you, it seems to work a little bit better. I'm going to talk in this video about two different situations. There are essentially two different cases where it's really important to find a square root in order to be able to solve a quadratic. The first of those two cases is when the quadratic only has one term in it that has x. If you ever find a quadratic that has only one x term, then you don't have to go through the factoring exercises that we've talked about up until now. You can simply use the basic Algebra 1 skills that you've had up until now to solve for x. So what we're going to do is we're going to move the 1 over just as we normally would have even if there hadn't been an exponent here. So I'm going to subtract by 1. Now I've got 2x squared equals 32. Then I'm going to divide that away, that 2 away, and I'm going to have x squared equals 16. And from here I'm going to take the square root of this to get x, so I'm going to have to take the square roots of both sides. The left side will be x. Make sure you're careful to notice here the right side isn't simply the square root of 16, it's plus or minus the square root of 16. Why? Well, look at this a little more simplified down. X becomes plus or minus 4. Negative 4 times negative 4 would also have been 16. Whenever you're taking the square root of x squared, you're going to find that the other side is always going to have plus or minus in it. Now, like I said, this is only one of the two scenarios where we're going to end up taking the square root. You'll probably notice that I started you off with example 2. We'll get to example 1 a little bit later. You might have also noticed that I put quotations and marks around this because I actually modified this equation. The textbook gave you 2x squared plus 1 equals 17. I'm going to go through this much more quickly because you can always read this example in the book. And you'll find that just as before, you end up with x squared equals a value, and when you take the square root of both sides, you get plus or minus. And in this case, x equals plus or minus the square root of 8. We don't know what the square root of 8 is, unlike the previous example I gave you where 16 was a perfect square. This time there isn't a perfect square to work with. For now, I'm going to stop us here. The textbook goes another step, and we'll talk about that in a later slide. I said there were two situations where you're going to want to take the square root, and that will help you to solve quadratics. Again, in this case, and this is the second scenario, you can solve for x without having to do any of the factoring or other things that we cross them up and split the middle as an example that we've done up until now in Chapter 5. In fact, it's very tempting, and many students do get a question like this and feel like, well, I might as well multiply x plus 5 times x plus 5, and end up foiling that. And what they end up with is a standard form quadratic equation that's actually harder to solve than where they were originally. This is a very easy problem to solve if you just realize that you can use your Algebra 1 skills. Move that 1/3 over. X plus 5 squared equals 36 now. Take the square roots of both sides. You've got x plus 5 equals plus or minus the square root of 36. The square root of 36 is 6, so you've got x plus 5 equals plus or minus 6. The last thing that's left to do is to move that 5 over. So it could be x equals minus 5 plus 6. It could be minus 5 minus 6. And remember that minus 5 plus 6 is equal to 1. Minus 5 minus 6 equals negative 11. And 1 or negative 11, those are your two values here for x. The textbook had actually given you a different number here. Once again, it had given you 7 rather than whatever I was working with before, 12. But it says otherwise the same problem. So again, I'm going to go through this more quickly than the first time through. Move the 1/3 over. take the square root of both sides, and now move the 5 over, and I've got x equals -5 plus square root of 21, or -5 minus the square root of 21, as this says here. Well, I don't know what the square root of 21 is. I know the square root of 16, which is 4, the square root of 25, which is 5. So this is somewhere between those. Let's say this is roughly 4.5. So my answer is -5 plus 4.5 and -5 minus 4.5, roughly speaking. You can always, as the textbook says, check your solution by plugging these two values both back in for x in the original statement if you wanted to try that. And obviously, using a calculator when you're working with the square root of 21 is going to be highly recommended. But if you did that, you would find that this would work. Either of these two values here, plugged in for x and worked through, will turn out to be 7. Okay, this is an exercise I want to encourage you to do. Hit the pause button and read this. Okay, I'm going to assume that you've read what it was that you've been asked to do here. What they're wanting you to do is to pull out a calculator, graphing calculator or not, it doesn't matter as long as it can take square roots, and compare the answers you get. Try the square root of 36, compare it to what happens if you do the square root of 4 times the square root of 9. Do all 6 of these. For example, this last one here, the first time you're going to do the square root of 19 divided by 7. And then the second time you're going to figure out what the square root of 19 is and divide that by the square root of 7. And see if you get the same values or not. Hit the pause button. When you come back, I'm going to show you the answers. Okay, I'm going to assume that you did that. In fact, you should have gotten the same answers. The square root of 36 is the same as the square root of 4 times the square root of 9. Just as the square root of 19 over 7 is the same as the square root of 19, then divided by the square root of 7. And here's a perfect example. You don't know what 4 divided by 9 is, so you don't know what the square root of that is. But you do know what the square root of 4 is. That's 2. And you know what the square root of 9 is. That's 3. So this is 2 divided by 3, as I've indicated here. Well, it turns out with your calculator, if you try this, the square root of 4 divided by 9 is also 2/3. So I'm hoping you're realizing, as it shows here in this excerpt from the textbook, that I can take two numbers that are inside a square root. If I want, I can break them apart. And I can have the square root of a times separately the square root of b. Sometimes I want to break them apart like this. In other cases, I'm going to want to put them back together and work the opposite way. This holds true when I'm multiplying. It also holds true, as shown here, when I'm dividing. So here are some examples. Square root of 75 is the same as these two broken apart pieces, the square root of 25 times the square root of 3. And likewise over here, I don't know what 36 divided by 16 is, but I do know the square root of 36, that's 6. And I do know the square root of 16, that's 4. So I've got 6 over 4 here, or in other words, 3 over 2. If I tried it over here, I would have gotten 3 over 2, but it would have been more work on the left side. So, similarly, if I'm given the square root of 75, I don't want to miss this sentence here. It's kind of tucked away in the textbook, and most students read right past it without noticing it. But this is a key point. We're often going to talk this year about whether or not a square root has been fully simplified. Here are the basic rules. There are 2 rules to determine whether or not a square root has been simplified. First of all, the radicand, in other words, this number inside a radical symbol, it cannot have any perfect squares inside it. If it does, then you should have tried to pull them out. Second of all, there can't be any radical sign in a denominator of a fraction. So let's look at this first one. Can I squeeze any perfect squares out of 75? Well, of course I can. We did it on the previous slide. Square root of 25 times the square root of 3. Last slide we left it here, but you can keep going because you do know the square root of 25. That's 5. 5 times the square root of 3 is as far as you can go, though, in terms of simplifying. This is finished. This original was not finished, not simplified. Why is it finished? Well, there is no step 2, rule 2, to even worry about because there's no denominator, there's no fraction. And rule 1 is also satisfied because the only radicand which is this number here, square root of 3, does not have any perfect squares inside it. So this is finished. Let's look at a second example, 1 over the square root of 2. Let me cover this up a little bit better. 1 over the square root of 2 is finished as far as rule 1 is concerned. But in rule 2 it says it can't have a radical in the denominator, and it does. I've got to find some way to get rid of that. This is trickier to do. The way to do it is to multiply this times the square root of 2 over the square root of 2. What I'm doing on the right side here is I'm basically multiplying my original value times 1. But the nice thing about doing it this way is root 2 times root 2 is 2. Then 1 times square root of 2 is the square root of 2. This may not look to you, and in fact I have to admit I don't think it is particularly better either, but this is not considered simplified. This is. So we're going to talk often about the importance of getting that radical sign out of the denominator. Okay, let's practice. The textbook gives us example 1, which I had skipped past at the beginning of this lesson, but now we can work at it. I've spotted you A here. Square root of 24 is broken apart. There is a perfect square inside it, and 2 root 6 is as far as I can go in terms of simplifying this. In this case, I broke apart to get work done. In B, I've got to put them together in order to get anywhere. And you're going to play at this sometimes when you're working with radicals in tonight's homework and going forward, because you don't know which way is going to enable you to do more simplifying. Well, I don't know anything to do with square root of 6 or the square root of 15, so I'm stuck unless I can put them together. When I multiply them, though, I get the square root of 90. That does have a perfect square in it, and I can keep going like it indicates here, and I'll end up with 3 root 10. Then I'm done because I can't do anything with the square root of 10. 7 over 16, taking the square root of that, well, I can do the two separately. I can take the square root of 7 over the square root of 16. When I do it that way, I know what the square root of 16 is, and I can finish off with square root of 7 over 4. This is considered fully simplified. Last example here, root 7 over 2. I don't know what the square root of 7 is. I don't know what the square root of 2 is. So this might seem fully simplified, but I can't have a radical in the denominator. So I've got to get that 2 in a different form. So like I did in the previous slide, I'm going to multiply it times root 2 over 2. And root 7 times root 2 is going to be square root of 14 over the full 2. This is considered fully simplified. I promised to come back to example 2, and now we will. We had left this as plus or minus the square root of 8. Now you know that you can pull a perfect square out of there, and so this should make more sense to you. In between this step and that step, they haven't bothered to write it, was plus or minus the square root of 4 times the square root of 2. You know that the square root of 4 is 2. So plus or minus 2 root 2 is the fully simplified version of the answer that we had calculated previously. Okay, we're not going to have time in this video to talk about goal 2, so I'll make a separate short video about that. That's the end of this video lesson, and the other one I promise you will be quite a bit shorter.